Okay, in this video, we're going to solve logarithmic equations, and pretty much we're just putting together what we've already learned in the previous videos and how to apply them. Okay, so here's the first example. By the way, this will be a pretty short video. Here's the first example. Log base 6 of 2x plus 3 is equal to log base 6 of 4x minus 1. So when you have the log with the same base on both sides, and if they're both in condensed form, so by condensed, I mean you only have one log on this side, one log on this side. Okay, so these are in condensed form. We can sort of cancel out the logarithms. And the reason we can do that is because, let's say if we wanted to get rid of log base 6, well, I would divide by log base 6, but then whatever I do to this side, I got to do to this side. So essentially, they just kind of cross out. Okay, but the shortcut, of course, is just to see if they have the same thing on both sides, and if they do, we can get rid of them. So we can cross out log base 6 on both of these, okay? Which leaves us with 2x plus 3 is equal to 4x minus 1. Essentially, whatever's inside the parentheses, okay? At this point, this is just algebra 1, so all we have to do is isolate the x values and solve for x. So we're going to go ahead and do that. We're going to go ahead and get rid of the 2x first right here because I don't want any negatives. So I'm going to go ahead and subtract 2x from both sides. That gives me 0 here. I'm left with 3 is equal to 4x minus 2x is 2x. And I bring down the minus 1. And then I'm going to go ahead and move the 1. So I do plus 1 to both sides, plus 1. 3 plus 1 is 4. Bring down that 2x. And my last step here is to divide by whatever is next to the x, in this case 2. Extend my line. Divide by 2 on this side as well. 4 divided by 2 is just 2, so my answer for this one is just x is equal to 2. And that's it. That is the first case you're going to see on your assignment today or tomorrow. So here's another example of what you might see. Example number 2, log base 2 of x plus log base 2 of 2 is equal to log base 2 of 4x minus 7. Okay. The first thing we want to check is if they are both in condensed form. If you look on the left side, we have two logarithms. So right away, you should know that this is expanded, meaning we have more than one logarithm. So we're going to have to take care of that first. Okay. So if you notice, we have a plus here in the middle. Remember that plus means we're going to multiply at some point. So let's go ahead and do that. We're going to turn these two logarithms into one log. So log base 2. And then we have x times 2. So you can do it this way, x2, but that looks a little weird. So I'm going to go ahead and rewrite it as log base 2. And I'll put the 2 first of 2x. That just looks a little bit more conventional. Okay. Bring down the equal sign and bring down whatever is on the right side. So log base 2 of 4x minus 7. Okay, so all that I did here is I combined these two into one logarithm. They gave me this right here. This is a different color. They gave me this right here. And this is the same as these two logarithms expanded. This is the condensed version. Okay, so now here you can see that this looks just like the first example where we had a log on both sides and they have the same base. So remember that if that happens, we can just cross them out and look at just the inside. So we are left with 2x is equal to 4x minus 7. Again, essentially whatever is on the inside of the parentheses. And we're just going to solve. Again, algebra 1 skills. So I'm going to go ahead and again move the smaller x to the other side. In this case, my smaller x is 2x, so minus 2x minus 2x. Be careful here because a lot of people get confused. If you cancel everything out, there is still a 0. Okay, so we're still left with 0 on this side. So 0 is equal to 4 minus 2 is 2, so 2x minus 7. Okay, and now that I have all the x's on one side. I want to move that 7 over to the other side. So let's go ahead and do that by adding 7 to both sides. That will get rid of the 7 on the right side. And 0 plus 7 is just, well, 7. So 7 is equal to 2x. And just like the problem before, we're going to get rid of the number that's next to the variable, in this case x. So we're going to divide both sides by 2, and therefore x is just equal to 7/2. Let's do that a little bit nicer. So 7 over 2. If you want to use a decimal, you can. It would be x is equal to 3.5. But me personally, I like to just stick to the fractions just because they're a little more accurate sometimes, especially when you have repeating decimals. But anyway, so there's your second case. We're going to go ahead and look at the final example. Example number 3, we have log base 3 of 2 plus log base 3 of x minus 8 is equal to 4. Notice that this one does not have any logs on the left side. So we're going to have to do something a little bit different for this one. But before we do that, let's go ahead and look at the left side here. Sorry, I meant the right side over here. We have the same logarithm, and again, we have another plus. So plus implies multiplication, so we're going to go ahead and do that. Log base 3, and then we have 2 times everything that's in this one, so x minus 8. And I'm going to put that in another parentheses because it's 2 times everything, not just the x, not just the 8, but both of them. So we'll deal with that in a bit, okay? So let's go ahead and rewrite this so it looks a little bit nicer. Log base 3, parentheses 2. Let's distribute that. 2 times x is 2x. 2 times negative 8 is negative 16. So this is what we have inside the parentheses. This part is this part right here. All equal to 4. Okay, now you have seen this case before. You saw it, I believe, on day 1 when we were rewriting logarithms. If you have a logarithm on one side and not on the other, you're probably going to have to rewrite it as an exponent. Okay, so we're going to rewrite this. The rewrite always starts with the base, so we start with 3. So there's my 3. We come around to the other side, so to the power of 4, and then back around, equal to all this, 2x minus 16. So hopefully you remember that a little bit. If not, it's okay. I'm just reminding you. Remember, this video is more of an application on everything you've learned so far. So it's just putting it all together. Okay. So we're going to go ahead and solve this now. 3 to the 4th is the same as, so this is the same as 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 3 to the 4th is just 81. So let's rewrite that as 81. 81 is equal to 2x minus 16. And at this point, we're just solving again. So notice that all of these problems, we're just solving for x. And they end up, after you deal with the logs and rewrite it and all that, they just end up as regular equations, 1 2-step equations. So in this one, we're going to add 16 to both sides. Okay, so 81 plus 16, let's see, 1 plus 6 is 7, 8 plus 1 is 9, equal to 2x. Okay, and we're going to go ahead and divide to get that x by itself. So let's divide both sides by 2. That gets rid of the 2 for me here. 97 is not going to be perfectly divisible by 2 because it's an odd number, so we can leave this one like this. X is equal to 97/2, or 97 divided by 2. And that's it. That is 3 different cases you might see for solving. There's obviously other cases you might see. We'll see if we get to those this semester. If we do, I'll go ahead and make another video. Okay, so hopefully you understood this, and I believe that will, if there is no other videos, that'll be the last one for solving. Okay, well, graphing will be next.